Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this even and odd problem of GFG. So let's move on to the problem guys. So here we are given input n and an array of containing n integers, and there is a condition that our array will contain equal number of odd and even numbers. Okay guys, so we have to modify the array such that all the even index should contain the even number and all the odd index should contain the odd number, and our indexing start from 0. Okay guys, so we have to return the modify array. So like for example this array. Okay, for this array how we will do it guys, just look at the approach. So this is index 0. I will decrease the size. This is index 0, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, so according to the question, this 0, 2 and 4 contain even number, this 1, 3 and 5 contain odd number after the modification. Okay, so how we will do it? So just give it a look. So guys, we are taken the first even index. We are taken two variable odd and even. Okay, now even is the first even index we have, that is 0, and odd is the first odd index that we have, that is 1. Okay guys, so now let's see what we have to. Yes, now we and we take a other variables called I. Initial it was 0. Now we will check the parity of I and ARRI. Parity of ARRI. Now what is parity? Parity means even or odd. If both of them are even or both of them are odd, means how can we check it? If I modulo 2 is equal to means both are equal means this is 0, this is 0, so means both are even, so we can say even index I contain even number ARRI. And or if this is 1, this is 1, we can say odd index I contain the odd number ARRI. Okay, so if these both are equal means our current ith element is at correct position, we have to move forward. We will increment I by 1, we will increment I plus 1, else why we will we will do some operation on even or with even or odd index. Just look at it. Okay, so guys, now we are at 0, so our I is at 3. Okay, now 3 is index is 0, ARRI is 3. So are parity same? No, here parity is 0, 0 modulo 2 is equal to 0, 3 modulo 2 is equal to 1, means these are not equal. Okay, these are not equal means either even index contain odd element, means it is or contain even element, or even index contain odd element. Okay guys, so here what we do, we will what operation we will do, we check the parity of this particular element, means check this element is even or odd. So this element is odd, so we will swap this element to first odd number we have, to first odd index. Now what is first odd index? It is 1, so we will swap index 1 with this index 0. Okay, so now after changing, how it will look like, they will look like it will become 3, this will become 6. Okay, after updation. Okay, after I can say this will look like, this will become 6, this will become 3, all the array remains same. Okay, now and our I will remain still point to this. Okay, I array point to 6 now. Okay guys, so now our I will remain 0. Now number became 6, at 0 index number became 6, so 0 and 6 have the same parity, means even index contain even number, so we increment our I, so means our I became 1. Now at 1 index we have 3, our I will point to now this number 1. Now one index contain 3, both have parity same, means odd index contain odd number, parity same, so we just move our I by 1. Now our I will become 2. Now 2 index 12, 12, it means parity same again, we will just continue again, increment our I, parity same means even contain even or odd index contain odd number, so 3. Now here 3 contain index 3 contain 1, both are odd, again move by 1. So now we are at 4. We are at 4. Sorry, 4 contain 5. I just erase it all. 4 contain 5 now. Now element index 4 contain 5. Parity different. So we will check the parity of this particular element. 5 means it is odd number. So we are after doing the swapping, we will increment our odd to next odd index, that is 3. Means 1 is 3, after 1 the next index odd index is 5, then 3, then 5, then 7 till up to n minus 1. Okay, similarly with 0 we will change this to 2, it to 4, means all the next even index possible. Okay, so now it is odd, so we will change it with 3, it will 3. So what is 3? 3 is this. So we will doing swapping of our, so now our this array will change again, this will remains 12. So now 1 and 5, 5 and this index 4 and 3 will go to swap. So this will become 5, this will become 1. I remains 4. I remains 4. Now at 4 we have just a minute. Yes, now at 4 we have 1. Okay, now these are not number. Now at 4 we have 1. We have 1. So is parity same? No, parity is still different. Okay, so what we will do, and I will update my odd as well. Now odd will point to our 5 index. Okay, because we have used 1, we have used 3, so now odd index is 5. So this is 4 and it contain 1, so parity are not same now as well. So we will do swapping between 4 and 5. Now swapping between 4 and 5, so how it will look like, 1 and swapping between 1 and 8, so it will become 8, it will become 1 now. Okay, and we will update our odd to 7. Not worried if it is content out of the n, because n is 6 here. No worry, because it means we have used our odd, means we have completely set up our array. Okay, we don't require odd anymore now. So even as well, but we can continue now. So now I is equal to 4. Now 4 contain 8. Parity same, increment I, means ith element is correct. Now parity is this. Now 5 contain 1. 5 contain 1 means fifth odd element contain odd element, odd index contain odd element. So increment I. Now I will come out of the loop, means I is equal to 1. So means we have just complete our function. This is the array that we have at last: 6 3 12 5 8 1. Okay guys, so I hope you understand the approach. Okay guys, so this is the array we will return at last. So now look at the code. So we are taken two variable, even and odd, starting even with 0, odd with 1. Now for I is equal to 0 to I less than n, if parity means I modulo 2 is equal to ARR I modulo 2, increment our I and just continue, means we don't need to do any work now. But else if parity are different, then ARR I modulo 2, if the number is even, then we will swap with even index number with current number and increase our even index with 2. Else while means the number is odd, swap our odd with ARR I and increase our odd index by 2. Then as last we just return. Okay, so now I am compiling it. You can see correct output. Now I will just try to submit it. So you guys can see all the 221 test cases pass out. So I hope you will understand the approach, and if you have any doubt then just comment out. I will try my best to explain you. Meanwhile, you can subscribe the channel, like the video and check out my channel for more these type of videos. Thank you for watching this guys.